In this question, we have to find all the horizontal asymptotes of this function. So the horizontal asymptotes, to find those, you're really trying to find the end behavior of the function. In other words, what we're trying to find is the limit as x goes to infinity of h of x. And, well, what happens in this case is as x goes to infinity, 3 over x, well, 3 is fixed. X is growing without bound, so 3 over x, oh, whoopsies. 3 over x as x goes to infinity goes to 0. So this limit is 8 minus 0, which is 8. And as x goes to negative infinity, it's the same result. 3 over x as x gets really large without bound, this ratio goes to 0. So again, we end up with 8. So here we see the horizontal asymptote for this function is at y equal to 8. Okay, here we want the horizontal asymptotes of the function, if any. So for this function h of x, in order to determine the horizontal asymptotes, we're going to look at the limit as x goes to infinity of h of x. And in order to evaluate this limit, we did this earlier in this section, we're going to divide the top and bottom by the largest power of x that appears. Because if we don't do that, I mean, there is no substitution. I mean, this is infinity over infinity, so that's unclear what that would be. So if we divide the top and bottom by the largest power of x that appears, then we'll algebraically see that this limit will settle down to a particular value. So when we do this algebraically, we have to distribute the 1 over x to the 5 to each of the terms in the numerator and denominator, and we get this result. And then you can see that it is possible to cancel, because x to the 4 over x to the 5, for example, there's a common factor of x to the 4. So you end up with this expression in the numerator, 8 over x, 5 over x cubed, 9 over x to the 5th, and the denominator, here, x to the 5th over itself is going to be a 1. So we have 5 and, these other terms. So what happens as x goes to infinity? Well, like before, as x gets large, this ratio goes to 0, this ratio goes to 0, also goes to 0, and the other ratios as well all go to 0. So in the limit, you end up with 0 over 5 or 0. So we have a horizontal asymptote at y equal to 0.